All right, we're going to use all of those things that we've been doing to do this FRQ. This is from the 2015 AP test. It was on the BC test. It looks like it was question number 6. It's the last one that they gave. It's kind of typical. They give a series question at the end after our brains are pretty fried from 3 hours of testing. But I want to show you that you can get some points from this stuff. All right, so let's read what they give us. So first off, they say the Maclaurin series. You should know what a Maclaurin series is, but they're just trying to confuse us with words, right? The series for F is given by this thing. So they give us the summation form, and then they give us the first 3 terms, and then the general term. And it converges for F, absolute value of R where R. So this is just sort of defining what the radius of convergence is. So we want to find the radius of convergence. You should know that that's half the length of the interval. So what are we going to do? We're going to use the ratio test. That's what it even tells us in part A, to use the ratio test to find R. So what do I do when we're doing the ratio test? I write L equals limit as n goes to infinity, absolute value. A sub n, I'm always going to write this a sub n plus 1 over a sub n. And that is equal to, all right, so I'm going to have absolute, whoops, I'm going to not drop my limit notation. Limit as n goes to infinity. Now I'm using this right here, absolute value. So we've got negative 3. What I want you to see is I'm just going to write to the n. Look, negative 3 to the n minus 1. If I plug in if I change n to n plus 1, then the plus 1 and the minus 1 will cancel each other out. So we just get n over n plus 1 times x to the n plus 1. I'm going to write that as if it's in the top because I know it is. And then I'm going to copy dot flip and leave everything else with n's. So I'm going to get an n in the top. Remember, this piece is in the top of the main fraction. So when I copy dot flip, it becomes in the bottom. So I'm going to get negative 3 to the n minus 1 times x to the n. Now we're doing the same thing that we always do, which is to reorder. Limit as n goes to infinity. I've got 3 parts. I've got negative 3 to the n over negative 3 to the n minus 1. Then I've got x to the n plus 1 over x to the n. And then I've got n over n plus 1. What's this limit come out to be? It comes out to be 1. We've talked about that a lot. How do these cancel? All of that with all of those, so we're just left with the x. And then the same thing happens with this. All of those cancel with all of those, and we're just left with that. So our next line is going to be limit as n goes to infinity of, I'm going to have a negative 3 times x times 1. And then this is a trick that came up in the previous one, where I'm going to write this is the limit as n goes to infinity. Absolute value, I'm just going to write it as, I'm going to drop the negative because I forgot the absolute value there. So 3x. Now, no n's. So what's the limit? It's just the absolute value of 3x. And what I want for it to be less than 1. So I'm going to scroll down and get rid of some of that stuff for now. That gives me, oops, not equals. That tells me that negative 1 is less than 3x is less than 1. I'm going to divide by 3 on both sides. Negative 1/3 less than x less than 1/3. So that would be the interval, not checking the endpoints. But what is half the length of this interval? Well, it would just be from 0 out to 1/3 or 0 back to negative 1/3. So the radius here is 1/3, and we should see that because, you know, if it was negative 4 less than x less than 4, for example, then that radius would be 4. So this is just 1/3. So get rid of this. And we'll check to make sure we found the answer to part A. Hopefully that makes sense. All right, so the next thing it asks for is the first four non-zero terms of f prime. Okay, write the first four non-zero terms for f prime, derivative of f, express f as a rational function, okay, for x in that R. All right, so a little confusing. If I want the first four terms of f prime, then I need to have the first four terms of f. So what I want you to see is I've got 1, 2, 3. I want to have a fourth term. So f, I'm going to write f is approximately, and I'm going to write those terms. I'm going to zoom out just a little bit so we can see it all. All right, x minus 3 over 2x squared plus 3x cubed. And then I need one more term. So what I'm going to do is plug into the general term. Notice it started at n equals 1. So n equals 1, 2, and 3. You do want to make sure that we started at n equals 1 and not n equals 0. So that means I need to plug n equals 4 into this thing. If you plug n equals 4 into that thing, we wind up getting minus 27 x to the fourth over 4. Hopefully you're okay with getting there. Let me come down here and kind of take the next steps. So it says, all right, so I want to find the first four non-zero terms of f prime. So what we're going to do is take the derivative. F prime is approximately, all right, I'm going to take the derivative of this line. What's that? It's 1. And then look, when I do my power rule here, this 2 cancels with that 2 and gives me just a minus 3x. And then the next one gives me plus 9x squared. And then the last one gives me the 4's cancel, minus 27x cubed. And then, all right, so let's read what it says. Let me zoom out again. I think I've done some of this, at least. So part B in red. All right, so find the first four non-zero terms for f prime, derivative of f. I'm good there. Express f prime as a rational function. All right, so this is similar to the previous video that I had. A rational function, let's see, does it give us more hints? Nope, it doesn't. So a rational function is just a function with a fraction in it. What they want you to do here is to recognize that this series is geometric. What is a sub 1 for this series? And what is the ratio for this series? Can you identify this? Given the last problem that we did, you might be able to do this. What's a sub 1? It's the first term. That's 1. That's this. Then the question is, what do we multiply to get from this term to that one, and then this one to that one, and then this one to that one? Well, the ratio is negative 3x. It's not just negative 3 because we multiply by x each time as well. So all we do from here is the same thing that we did in the previous one, and it's actually the same function. S sub infinity is, I guess I should go back to the question so you can see it. It says, write it as a rational function. Remember, S sub infinity for a geometric series is the first term, a sub 1, over 1 minus the ratio. Well, that is, a sub 1 is 1 over 1 minus the ratio gives me a double negative plus 3x. And that is the answer to part B. It's a rational function. I've written it. Kind of weird, but hopefully it makes sense to you. Okay, so that is how we do A and B. Now we'll talk about C. I moved all the work for that down here. Hopefully all this makes sense for A and B. Let's go ahead and look at C. This is B. All right, so I moved that out of the way so that we could zoom in on this more. All right, so let's see what it says. Write the first four non-zero terms of the Maclaurin series for e to the x. what we're doing in this one is similar to some of the things that show up in some multiple choice questions. Specifically, there was, I think, one on the 2012 test that you might recognize here. So it says, write the first four non-zero terms for the Maclaurin series for e to the x. I'll go ahead and do that. We should know, and you should know, that e to the x, the first four terms are going to be 1 plus x squared over 2 factorial plus x cubed over 3 factorial. That's 4 terms, so we're good to go there. It says use the Maclaurin series for e to the x to write the third degree Taylor polynomial for g of x. Okay, there's a new function g, which is e to the x times f of x. Remember, they gave us f up here. So what we need to do is find e to the x times f of x. Now this is like, wait, what? But we just do algebra the same way that we do with any old algebra, except for what I'm gonna do is I'm gonna take this guy and I'm gonna multiply it by this guy, because the blue that I circled, or this one that I circled, is f of x, and this one down here is e to the x, and this says e to the x times f of x. So let's go ahead and write that out. G of x, do it in red, is e to the x times f of x, which is approximately, all right, I'm going to write e to the x as series, 1 plus x squared over 2. I'm going to write it out like that now. And it says the first four, first four non-zero terms. All right, so plus x cubed over 3 factorial, I'll write that as a 6, times, all right, f of x is, I'm now copying these pieces here. So x minus 3 over 2x squared plus 3x cubed. All right, so now I'm going to give myself a little bit more space. What I'm going to do is multiply things out, and I'm going to stop when things become unnecessary. So I'll do it in purple. I'm going to do this one times 1, 2, 3. So that gives me x minus 3 over 2x squared plus 3x cubed. Now I'm going to do, go to green, this times 1, 2, 3. That gives me plus, all right, I'm going to get an x squared for the first term. I'm going to get minus 3 over 2 x cubed, and I'm going to get plus 3x to the fourth. Now we'll go to purple. No, yeah, we'll do yellowish. Okay, so this is a 4. Now, so I'm going to get this times 1, 2, 3. That's going to give me, all right, here we go. All right, so I paused and did them out like this. You can verify this, that this is those multiplied out. Now, look, it says find the first 4 non-zero terms. So what does that mean? Sorry, take that back. It says third degree. So that means that I don't need to consider anything that is less, that has more than an x cubed in it. So this one I can ignore because it's x to the fourth. Oops. This one I can ignore because it has x to the fourth, and this one I can ignore because it has x to the fifth. So if I combine these terms, or I could leave them in, quote, AP form, if you combine them, we wind up getting x minus x squared over 2 plus 2x cubed. That's what you get when you combine all the remaining terms here. And that's it. All we did was multiply this one series by that one series and then kind of FOIL it out. There's other problems that show up like these. Hopefully, you feel like this is reasonable to get maybe half the points. Maybe you can do better. But that's Taylor series FRQ. Thanks. Bye.